I have not rehearsed this at all. I kind of want this to be an interactive thing. So I'm just going to go ahead and show you what the application is that I've done. Then you please tell me what you want to know, what you want to see, how it's done, and I will try my best to explain how it's done. My service is this. This is my local copy, but I will show you the one that's running online. So trains.today, the best domain purchase I've ever done. I think it was like 199 for the year, and I was the one that got it. So this is a service that uses the Digitraffic open data APIs. It's a schedule service for trains in the Helsinki region. So you select a place where you want to leave from, a departure station, and then a destination station. And then you get the live data for when the next trains are going to leave, what kind of trains are they. If we take the other way, we see that there's a train running currently in Kauklahti. It's on time, has been on time in Kauklahti, and looks like the estimates are also on time. It's going to arrive in about a minute and a half. It has 2 cars, and it's going to leave from the platform 2 and arrive at the platform 15. Any questions what the UI means? Or
So what happens when there starts to be weather delays and they start announcing over the intercoms all these trains are being delayed?
right,
I mean, in terms of your app, like how does it update and
yeah.
account for that?
So Digitraffic is essentially the Liikennevirasto. So it's the governmental organization in Finland that governs all of the transport in Finland. So this data is very accurate. It's very like precise. It's very much on time. So when some kind of disturbance in the train traffic is happening, it is very likely that it's shown here. I have some screenshots of the older versions at least to show you what it looks like when there's like major issues. I think it's also on the GitHub repo, yeah. This was a morning when all the A trains were cancelled, or at least half of them, something like that. And then something that's very uncommon is that even for trains that have not yet departed from the departure station, they also had like delayed estimates. So this is what it looks like. This train up here is moving. It's 5 minutes late in Leppävaara, and these are the estimate times for being in Leppävaara and being in Pasila. Again here, 2 minutes late leaving from Leppävaara, even though it's like 13 minutes until it's gonna leave. Anything else?
Is it actually is it polling or do you have some push mechanism yet?
This is polling. So if you take a look at the requests that I'm sending, these are happening basically at 10-second intervals. It's basically just due to the fact that this particular API does not support any sort of WebSocket stuff. There are other ways of getting the same data basically using WebSockets, but it's not exactly the same kind of request that I'm sending. So I would need to sort of modify the entire structure of the code in order to mitigate that. And there's another problem with WebSocket updates, which is that you would then only get things that change, which means that I would somehow have to know when to still get the entire data set so that then I can apply the diffs on top of it. And it's a bit complex, like, do I do that every 15 minutes, or it's not that easy to come up with a foolproof logic for that. So yeah, it's not that sophisticated in the data sense, but it does the job and it seems to be very reliable. It's never down. I've never seen it being down. Okay, so the code is Elm. This is actually a test file that I have open here. So yeah, I'm not going to be able to show you all of the code that I have. The model.elm file is like 460 lines. And this is mostly about the data formats and data transformation, because the JSON format is not very like down to the point. It's basically every single train has timetable rows for arrival and departure for every single station that it passes. Not even the stations that it stops on, but it passes. So there's like a metric crap ton of unnecessary data. So the model.elm file is where I basically prune it down to format that makes sense for my use case. So this is what my train type looks like. There's like train number. I don't even show it in the UI, but it's something that I use for finding specific trains in the code. Then there's line ID, which is the name of the train. So it's like U or P or I or Z train. Is it running currently? Boolean. Is it cancelled? Boolean. What is the current station that it's on? That's a maybe. It might not be moving, which is when it doesn't have a current station. Then home station arrival is the timetable row for when that particular train arrives on the station that you are leaving from. This is also maybe, because if you're leaving from Helsinki, for example, it never arrives there. It only departs. So that's why I have also the home station departure, which is not a maybe. And there I can certainly get the times and estimates if they're available. I like to use the arrival for cases where, for example, I'm leaving from Kilo, which is in the middle of the track, basically. So I like to use the time for when does my train arrive on the station, because that's like what I'm interested in. When does the train come to me? I'm not that interested in like when is it gonna leave. I just want to get in. Then there's end station arrival, which is when the train comes to the station that I want to go to, and that's again forced to be there. I essentially filter out all the trains that don't stop there. Then there's duration in minutes for the entire trip, how many stops there are in between, and does it go via the airport? This is interesting. This is something that I just added. But on the Kehärata, I don't know which stations you know, but the train can go basically from Huapalahti to Pasila, like straight or the entire way around. And there's like 40 minutes of difference. The API still gives both of the options because, yeah, you can get there. And so by default, I'm not showing the trains that go via the airport, but in some cases you might want to. That's an interesting UI thing. But yeah, can you just ask me some questions, please?
So where do you store the delays? You don't have any delay information here.
So delays are in the timetable rows themselves. So this is what it looks like. There's like the scheduled time is a time. POSIX is just a time format. So there's actual time and live estimate time and difference in minutes. These are all things that come from the API, possibly. They might exist or they might not. So I use them strategically.
Briefly show how the JSON parsing from the API response to
Yeah.
this looks like.
Yeah, I was sort of scared that this would come up because, as I said, the JSON is weird and I want to come up with this train raw is what I actually get from the JSON. So that's like very basic stuff. Train number, line ID, category, timetable rows, running currently, cancelled. But timetable rows is, again, as I said, every single row, like every single arrival and every single departure. So it's a bit of a hassle to go from here to this thing that I actually want to show in the UI. So I have this trains decoder. The decoder is like basic and up until a point. So these first things up until the cancelled are things that normally exist in a decoder. And then I do some weird stuff. So I basically pass it through to this toTrain thing that I made, which is essentially a super convoluted way to get from a raw train to possibly a train, because there are so many things that might go wrong. And then I check if it's valid, and there is a home station departure, and there is an end station arrival. And if all of those things are true, then I can build this thing that looks like the train that I want. But if any one of those things is not true, then I just can't deal with the data. It's nothing then. So yeah, this is the most complicated thing that I have here. I don't know if you want to actually know what this does, but just as an example, like I have this helper called find timetable row. So I try to find a departure kind of row that matches the station that I'm coming from the timetable rows that have not yet passed. And the way that I know if it's passed or not, if it has. But yeah, like this is the most complicated thing. Like I try to do all of this at the JSON decoding phase, because that only happens every once in 10 seconds. It doesn't happen on every screen refresh. I could do all of this filtering and like figuring out if this is the right way or the wrong way for the train. I could do it in the view, sure, but then it would happen on every refresh basically.
So is that you store it in local storage for persisting between refreshes, or how do you?
Oh, I mean refresh meaning a new request.
All right. So if you refresh the page, it actually fetches the data.
Yeah.
Okay.
Yeah. I do store the settings in local storage. So I don't know if you noticed, but there's the language selection. So the language selection is up there. If you take Swedish, refresh, it will still be Swedish. The route is in the URL bar. It's not easy to see here, but it's using the shortcodes for the stations. And that reminds me of a funny issue I had. There's a station called Mäkkylä, which has the shortcode of MA umlaut K. So this used to be, oh yeah, there's no trains from Mäkkylä to Kila, sorry. That's a hard problem to solve, showing only the stations that actually have departures. But yeah, this URL is now Mac/HKI. So I need to also do some URL decoding to to the hash URL that I have for getting the actual string. I guess the Elm developers didn't realize that fragments might have non-ASCII characters.
Yeah, regarding the JSON hassle thing, have you ever considered creating some sort of intermediate backend or something that would do the cleaning and maybe caching that stuff, or are you happy with the performance and stuff with the Elm code purely?
Yeah, I am very happy with the performance. There's like literally no issues with that. And honestly, I much prefer doing this in Elm than, let's say, a Node backend, because I would have no idea if it's gonna go wrong or not.
Also, the API is free and allows a request from any domain, so
Yep,
this is you don't need to pay for a backend this way.
it's open data.
What about if I think HSL at least has some GraphQL API. What if this
Oh
was
yeah, they
available?
actually do have one now. They didn't have one when I started this project.
But how complicated would it be to
I have
make this as a GraphQL query?
like I don't know. So there is a GraphQL thing, and it's not like perfectly documented. There's some examples. So I'm not familiar with GraphQL, so I really cannot figure this out. So I really don't know how difficult it will be to do that in GraphQL.
Is there anything in Elm that you think is particularly elegant or interesting, as say opposed to like standard JavaScript approaches for the same thing?
Well, I think the beautiful or elegant thing about Elm is that I have this thing that I've been building for fun for like 2 years on and off. I can still jump in and like just get going, and the compiler will still tell me what's going wrong. And I never have that experience with a JavaScript project. It's like I can basically just focus on what I'm doing and not so much on how it's like built and what kind of libraries have changed and so on. Otherwise, like it does help a lot that I can model the data, like model the domain problem in a powerful way, like using these sort of abstractions, even if it's for my own purposes, because it does help me understand what I'm doing and gives much better like error messages again. I was actually thinking if I should clean up this file before showing it, and then I figured that it's a pretty weird reason to refactor, that it's like maybe better looking for someone else, because I really haven't felt the need to do any refactoring, even though it's like 460 lines of code and in no particular order, because there's no possibility for any kind of clashes or any mix-ups. Like, say I have this stations decoder thing here. If I were to say here that I'm gonna redefine stations decoder here, just like the compiler is gonna notice immediately, and it says that there's a name clash. There's one here and another one here. So there's no way that I'm going to inadvertently like change something that I've done before. Let's see, the translations are kind of funny. They are type safe as well. So like the journey duration that's on the top of each train, this one, it's something that takes a record of this shape: duration minutes, slower by, fastest name. And in the view, let's see, what was name? Why does the find not find it? No results. What? Well, let's take another example. Schedule page, time difference. Well, it's right here. So if I were to, like, if I don't remember that it needs those, parameters, then I will get an error that these are not the same kind. If I try to put a string in the place of an integer, it's still not okay. Like even the translations are type safe. Like I don't know if I would ever have had this sort of patience to do even in TypeScript, because there's so many escape hatches. It takes so much effort to keep on the straight and narrow sort of even TypeScript. But with Elm, it's just like the status quo sort of. You just do it because this is the best way to do it.
All right, I think we are running out of time as well. So
Yep.
thank you, Ossi.